Good day, everybody. Good morning, good afternoon, good evening, wherever you are watching from. I appreciate the fact that you are here waiting for me to do some presentation. Today, we have to talk about variability. You've heard me talking before about collecting data, collecting information on topics like people's ages, such as suppose an university wants to find out what is the average age of the students at the campus. Now you have to conduct a survey on a sample of students and you will find out that the ages are all over the place. Have you ever wondered why there is so much variability in the data? Why the age, the variable in this case, varies from person to person? Hey, such is the fact of life, but how can we handle that information? Okay, what is too much variable, what is too much variation, and what is too less variation? How do we analyze the information from the data or information sets of data that we have collected? Okay, so variability is part of life and it's part of statistics. Again, as I have mentioned before, statistics is the process of collecting, analyzing, and interpreting information from surveys. For example, like the example I gave at the beginning, ages. But the question I want to pose is, what do you do with variability? Numbers will vary from person to person. It's part of life. So everything you know about variability is not correct. There will be ages will not be constant, right? From people to people it will vary. Okay, so variability is, as you can imagine, the word variability comes from the word variation, or which means in this case change in the in a particular characteristic. From subject to subject. Hey, you have to have some variability in your data. It's part of life, part of life. Okay. So let's talk about doing a survey on the campus with a sample of 50 students, and we ask each student, what's your age? So they will, you might get numbers like 18 years, 3 months. Another can be 18 years, 6 months. Another can be 19 years, 1 month. Another can be 17 years, 6 months. So as you can see, the ages are all over the place. So different, we note, immediately we note there's difference in age. Difference in age. Differences in age among students. Okay. So we conclude that ages of students will vary but how much variability is acceptable? That is the question. So please do not quit right away, because I will give you some important paper hint at the end of this program. And please take a look at my channel. Here I've lectured on all kinds of topics. I've also worked out problems just to help you. So please subscribe to my channel by hitting the red subscribe button. Moving forward, okay. Suppose one student in the sample of students that we are surveying, is 16 years old. Okay. Will 16 years age be considered unusual? Okay. So suppose we want to calculate, of course our goal is to find the average age of this sample of students. Should 16 be included in calculating the arithmetic average age? Of students in the sample? Okay. If we do that, if we include 16 in our calculation of the arithmetic average, it will influence the average age. Influence means it will pull the arithmetic average age towards it. Notice 16 is way below the averages, below the ordinary ages. 18 years 3 months, 18 years 6 months, 19 years 1 month, 17 years 6 months. These are some sample data points, and suddenly we get one student who is 16-year-old. So if I include that 16-year-old in calculation of the sample mean age, the number 16 will pull the arithmetic average towards it. Okay, will influence the arithmetic average. Now, from the sample mean age, we will make an educated guess about the population mean age. Population means all the students in the campus. Population mean age. Question is, did we take a risk? Take a risk or chance of making a wrong conclusion about the population mean age. Why? Because we included 16, which is a very small number compared to the rest. Population mean. Again, we included 16, that might have incorporated a risk. Risk is nothing but chance of making a wrong conclusion about the population mean age. Okay. So statistics, and this was my hint at the end. Statistics establishes rules for identifying exceptionally large or small number in a data set. And this large number or small numbers appear because of variability in a data set. So again, let me go over what we covered today. We talked about variability. What is variability? Comes from the word variation, characteristic changes from subject to subject, person to person. Age, for example, age in a sample of students will vary, change from person to person. Now, there is a normal range of ages. Suddenly, if we get a too small number as an age of a particular student who is younger, much younger than the rest, then if we include that younger student's age in the calculation of the average age of all the students in the sample, the younger student's age will pull the mean towards it. In other words, the average age will come out lower than what if we had not included that very young student in our calculation. Now the question is, what is an exceptionally low number or exceptionally large number in a data set? As I expressed, as I told you, if I include a very small young student's age in the calculation, it will pull the mean towards it. Thereby, the mean of the sample will be influenced by the presence of the very small number. Vice versa, on the right hand side, a very large number in the data set will influence the mean, will pull the mean towards it. The question is, which numbers should be considered as exceptional, that is too small or too large? And these numbers appear because of variability in the data. The important thing to notice here is at the end, the statistics, as you will learn later, establishes the rule for identifying exceptionally small number or exceptionally large number in the data set. And the idea is, once we have identified those numbers, we should redo the calculation for the average by eliminating those very small numbers or very large numbers. Why? Because from the sample mean, we will make a prediction or a forecast for the population mean. And if we include the very small or very large numbers, The sample mean will be influenced, as also our guess or educated guess about the population mean will be wrong. Hence, we should follow the rules which we will learn later in this course that statistics has established for identifying exceptionally small numbers and exceptionally large numbers. I'll stop here today. Any question, please do not hesitate to write me a small note. I will respond to everybody's inquiry. I promise. Okay. And if you like this video, please give me a thumbs up. If you like this video, share with your friends. And please do not forget to subscribe to my channel by hitting the red subscribe button at the bottom right corner. And please do not forget to check me out tomorrow. Also, please click on the notify button. That will notify you every time I upload a new video. Remember, the notify button is the bell button. Okay. Thanks for watching. Thanks for taking time to spend some time with me. I'll see you next time. Take care, and please do not forget to check me out tomorrow when I'll be back with something new. Take care. Have a nice day. See you. Bye.